Section 2.6, a library of functions. Here we have 8 different functions, and these are some common functions that you'll see throughout. So the first one is f of x equals c. That's a constant function, okay? So you can think of f of x equals a number, all right? And that's going to be a horizontal line. The identity function is simply f of x equals x, or y equals x. That is a line that passes through 0, 0, and has a slope of 1. Our squaring function, or our x squared function, is our typical parabola, okay, a basic parabola that has a minimum at 0, 0. We have the cubic function, we have the absolute value function, square root function, cube function, and reciprocal function. So just some common functions that you'll see as we go on throughout the semester. Example 1. Write a linear function that has the indicated values, then sketch the graph. So notice we're talking about function notation here. So as far as function notation goes, we have to go ahead and write out what ordered pairs we're actually given. So this first one, f of 1 equals negative 1, means we're given the ordered pair 1, negative 1. The x value is 1, the corresponding y value is negative 1. We're also given the ordered pair 3, 5. Okay? So if you recall back to a previous section, we need to write the equation of the line that passes through these 2 points. So the first thing we need to do is figure out the slope. Okay? So I'm going to label these x1, y1. Oh, that's a y, y1. x2, y2. Remember that slope is y2 minus y1 divided by x2 minus x1. That gives me a slope of m equals 6 halves, which is equivalent to 3. Now, once I have the slope, I'm going to go ahead and pick one of these points to use. I always like to use the positives. So I have a slope of 3 and a point of 3, 5. And I'm going to use y equals mx plus b to plug those values in and solve for the b. So my y is 5 equals my m is 3, my x is 3, and I have plus b. I'm going to go ahead and solve that. So that gives me 5 equals 9 plus b. I'm going to subtract 9 from both sides, and that leaves me with b is equal to a negative 4. All right, now that I have my b and I have my slope, my equation is y equals 3x minus 4. All right, well, this problem asks us to not only find the equation, but to sketch the graph. Now let me go back. It says write a linear function. So technically we should have f of x equals 3x minus 4. Okay? So now, negative 4 is my y-intercept. So I'm going to go down to negative 4 and put a point. Let's try that again. All right, and then my slope is 3. Remember, it's 3 over 1. So I'm going to rise 3 from there and go over 1. All right, then I can go ahead and connect my points, and I have my line. Example 2. Suppose the average maximum breathing capacity for humans drops linearly from 100% at age 20 to 40% at age 80. What age corresponds to 50% capacity? Okay, so they tell us right here that we're going to have a linear equation, a linear relationship. So what I want to do is I want to take the information that they give us and look at it as ordered pairs. So I have 100% at age 20. So I'm going to write that as 100, 20. Okay, so this represents my x values are the percentage, the y values are the age. My other ordered pair is 40, 80. All right, so now we're back to what we were just looking at in the previous example. We're given 2 points, and we need to find the equation of the line. So the first thing we need to do is find the slope. Remember, slope is equal to y2, so 80, minus y1, which is 20, divided by x2, which is 40, minus x1, which is 100. So I have 80 minus 20, which is 60, 40 minus 100, which is negative 60. So that leaves me with a slope of negative 1. So now I have my slope is negative 1, and I pick either ordered pair to deal with. It doesn't matter which one you pick. I'm just going to pick the first one. So I'm going to use the point 100, 20. I'm going to use that information to write my equation. So remember, we're talking about slope-intercept form, so y equals mx plus b. My y value is 20. My slope, or my m, is negative 1. My x is 100, and I'm solving for b. So I now have 20 equals negative 100 plus b. I'm going to go ahead and add 100 to both sides. And that leaves me with b equals 120. All right, so over here I now have the equation y equals negative 1x plus 120. Oh. Let me try to erase that. All right, there we go. Y equals negative 1x plus 120. Okay, so this is the equation that models the situation that's happening in this problem. Now the question asks, I'm going to go back up here, it says, what age corresponds to a capacity of 50%? All right, so what they've given us is they've given us an x value of 50, and they want to know what the corresponding y value is. So I'm going to go ahead and plug 50 into this equation. So y equals negative 1 times 50 plus 120. That leaves me with y equals negative 50 plus 120, which is y equals 70. So let's go back up and look at the question. Again, it asks, what age corresponds to 50% capacity? And our age is 70 years. Example 3. A company publishes textbooks. It costs $3,500 in fixed costs to set up the printing of the textbooks, and $2.20 for each book it prints. If the company prints X number of books, write a function C of X for the total cost to the company for printing the X books. Then calculate the cost of printing 20,000 books. So the first thing we need to do is figure out what our equation is going to be for cost. And they tell us to use C of X for cost. All right, so we have a fixed cost of $3,500, and then we have $2.20 for each book. All right, so $3,500, my fixed cost, is going to be my initial value. All right, and then it's going to cost an additional, so plus $2.20 per book. So I'm going to write that as 220x. That is the equation I'm going to use to calculate the cost of printing these books. The initial $3,500 plus 220 per book, so 220 times x. Now it asks, then calculate the cost of printing 20,000 books. So I want to know what the cost is. So what is C of x of printing 20,000? So really, what is C of 20,000? That means I'm going to take 20,000 and plug it in for x. So 3,500 plus $2.20 times each book, which is a total of $20,000. All right, so that's going to give me a total of $47,500. Whoop. Too many zeros. There we go. $47,500 is what it's going to cost to print 20,000 books. In this section, we're talking about a library of functions. So we're talking about different types of functions that we can use in algebra. So the next type I want to discuss is what's called a piecewise function. In the definition of some functions, different rules for assigning output values are used on different parts of the domain. Such functions are called piecewise functions. So what that's telling us is that we're going to take pieces of different functions and put them together to create the function that we want to use for a certain situation. Example 4. In Peach County, Georgia, a section of the interstate highway has a speed limit of 55 miles per hour. If you are caught speeding between 56 and 74 miles per hour, your fine is $50 plus $3 for every mile per hour over 55. For 75 miles per hour or higher, your fine is $150 plus $5 for every mile per hour over 75 miles per hour. We're going to define our function as f of x. So let f of x be the piecewise function that represents your fine for speeding at x miles per hour. And we're going to express f of x as the piecewise functions shown below. So if you are traveling between 56, including 56 miles per hour, and 75, so anything between 56 up to 75, then our function is 50 plus 3 times x minus 55. If you are traveling at 75 miles per hour or over, we're going to use this other function, 150 plus 5 times x minus 75. Okay, so depending on how fast you're traveling, we're going to use a different function to calculate the fine. Part A says, what is the fine for driving 60 miles per hour? Notice that 60 miles per hour is going to fall in this range, this first range, all right, between 56 and 75. That means we're going to take this 60 and we're going to plug it in for x in this first value. So 50 plus 3 times x minus 55, so 60 minus 55. All right, that's going to leave me with 50 plus 3 times 5, which is going to give me 50 plus 15 for a total of a fine of $65. So if you're traveling 60 miles per hour, the fine is going to be $65. Now, what happens when you're traveling over 75 miles per hour? For example, what is the fine for driving 90 miles per hour? So 90 miles per hour falls in the second portion. All right, anything greater than or equal to 75. So we're going to use the second portion of this piecewise function, 150 plus 5 times x, which is 90, minus 75. So that's going to leave me with 150 plus 5 times 90 minus 75 is 15. All right, we're going to keep calculating. That's going to leave me with 150 plus 5 times 15 is 75, and 150 plus 75 is 225. So if I'm traveling 90 miles per hour, it's going to be a fine of $225.